Alright, let's look at the practice exam 1, problem number 10. Alright, so we want to use a trig substitution to evaluate this integral. Right? So since we have a square root of x squared plus 4, this is the tangent one. Right? So we're going to let x be, right, 4 is 2 squares, so it's going to be 2 tangent of theta. Right? Then we can take the derivative of x with respect to theta. We get 2 secant squared of theta. Right? Then multiply through by d theta to find expression for dx. So that's 2 secant squared of theta d theta. Alright, so let's rewrite this integral here using the substitution. So you have an integral 1 over, right, x squared would be 4 tangent squared of theta, and the square root of, again, 4 tangent squared of theta plus 4. Right, then dx is 2 secant squared of theta d theta. Alright, let's simplify here. Alright, so let's look at this square root expression here. So square root of 4, so pull that out. So that's 2. Right? You have a tangent squared plus 1 once 4 is factored out. That's secant squared with the square root, so it's going to be just a secant of theta. Right? So we can cancel 2 on top and a 2 on the bottom, and 1 of the secant cancel. Right? So I can just scratch the square out. Alright, so what's left is going to be, alright, so you have a secant squared, secant of theta on top, and then you still have 4 tangent squared of theta, right, and d theta. Right, so let's rewrite this in terms of sine and cosine. Right, so this is going to be, right, 1 over 4 is just a number, so kick it outside of the integral. Right, secant of theta is 1 over cosine, so I'm going to write 1 over. I'm going to write it this way, 1 over cosine of theta. So cosine is going to be on the bottom. Alright, tangent squared would be sine squared over cosine squared. That's on the bottom, so it's the sine squared on the bottom, and divided by cosine squared. So actually I'm going to put the cosine squared up here, right, because it's reciprocal. And then you have a d theta. Right, then we can also cancel cosine of theta here, and then scratch this guy out. Alright, then we can use the regular u substitution to finish it up. Alright, so we let u be sine of theta. Then you take the derivative of u with respect to theta. You have cosine of theta, and take the reciprocal of both sides. D theta over du is equal to 1 over cosine of theta. Then multiply through by du. We get d theta is equal to du over cosine of theta. Right, so this can be rewritten as 1 over 4. Right, I'm going to leave the cosine of theta as it is on top. Right, and the sine is u, so it's a u squared. And d theta is du over cosine of theta. So we can cancel those out. So cosine and cosine, so you have a 1 on top. Right, so if you clean it up, you're going to get the 1 over 4 integral, right, and it's I'm going to write it as u to the negative 2 power du, right. Then we can find the antiderivative, since this is just a power rule. Add 1 to the power, so u to the negative 1 power over negative 1, and plus some constant c. Alright, then so originally u is sine, so this we can rewrite it as, right, so there's a negative, right, and a 1/4, right, so it's going to be a reciprocal of sine, so we can write it as cosecant, right, cosecant of theta plus some constant c, right. So we need to find the cosecant there, right? So let's draw a right triangle, right? Just a general right triangle, right? So right triangle here, right angle there, and let's say this is going to be theta, right? So use the original substitution equation here, right? And divide through by 2, we get tangent of theta is equal to x over 2. Right, and a tangent is opposite over adjacent, so we can let opposite to be x and adjacent to be 2. Right, then hypotenuse is using Pythagorean theorem. It's x squared plus 2 squared. That will be 4. Alright, if you want to find cosecant of theta, right, it's going to be, right, so this is a reciprocal of sine, so it's going to be hypotenuse over opposite, right, which means that, let's see, a hypotenuse is square root of x squared plus 4, and then opposite is x, right? So therefore this can be rewritten as negative, right, square root of x squared plus 4 over 4x plus some constant c. Right, so this is the integral that we are looking for. Right, that's it. I hope that this was clear.